So this is another example, square law modulator. So from the name itself we can say that it is obeying square law. So whatever you are giving the input at the input terminal, that is going to be squared. If you are applying the power level as 4, you will get the output as in terms of 4. So square law modulator simply square the input signal. So the non-linear portion of VI characteristics of diode is used as the element for non-linear modulators. This is situated as low level because of the fact that the voltage and current relation characteristics of a diode is highly non-linear, particularly in the low voltage region. So a square law modulator has 3 features which is shown in the figure. One is summer, the second one is non-linear element, third one is band pass filter. So the principle of operation, so this is the circuit diagram and it is a block diagram. So here we are applying our carrier signal and input signal. So modulation takes place in the non-linear device. So the non-linear device may be diode or a transistor. So whenever the device is getting a positive voltage which is greater than the threshold level, automatically the system start conducting. So this is the basic principle. This filter is a low pass filter. This is only allowing the required band of frequencies. It cut the remaining frequency. So this is the operation of square law modulator. So the output of the tuned circuit will be carrier and 2 sidebands, that is amplitude modulated waveform is produced. So let us see the mathematical analysis of the circuit. This is your modulating signal EM sin omega mt, carrier signal is EC sin omega ct. So the input voltage applied to the diode will be addition of these 2 signals. So that is why we have summer in the block diagram. So EM plus EC, so this is the outcome of summer. We know that the current and voltage relationship of a linear circuit is I is equal to AV. Then the current and voltage relationship of a non-linear circuit may be expressed as square law, that is I is equal to A V1 B V1 square plus C into V1 cube plus D into V1 power 4 and so on. So this means the non-linearity in the VI characteristics of a non-linear circuits, the current becomes proportional not only to the voltage but also the square cube and higher powers of voltages. So we can write I is equal to AV1 plus A2 V1 square plus A3 V1 cube and so on. So I is equal to A1 into, what is our V1? EM sin omega mt plus EC sin omega ct. Similarly A2 into the same input signal is going to be considered. The only thing is, according to the principle, it is a square law, so we are squaring the second input, then cube, and then power, we apply the power of 4 and so on. So neglecting the higher order coefficients. So second order and higher order terms are eliminated in the above equation. So we will get I of t is equal to A1 EM sin omega mt plus A1 EC sin omega ct, and the first terms are allowed. Then the DC component present in the circuits is eliminated with help of filter. So your I of t becomes A1 EC sin omega ct and the first term alone, the first term which represents upper sideband and lower sideband of the modulated signal. So we got our AM waveform. The main drawback of this diode modulator is it does not provide amplification, and a single diode is unable to balance out the frequency completely. So these limitations can be eliminated by using amplifying the devices like a transistor are fit in a balanced manner. So that is the beauty of square law modulator. So the same conditions applied here also, but we are introducing the transistors instead of diode, but in the balanced manner. So here we are going to apply the carrier signal, and here the modulating signal is applied in between the emitter terminal of both of these transistors. So the basic principle of this circuit is, whenever the input signal, carrier signal and modulating signal are added, the transistor 1 and transistor 2 is going to be operated. If the outcome of the nonlinear device is positive or positive half cycle, then this transistor will be operated in forward bias mode. So it starts conducting. So during the same time, this second half is receiving the negative half cycle, so it is reverse biased. So there is no current flow in this direction, whereas for a negative half cycle, for the upper half of the circuit, this will be operated in the reverse bias mode, this is operated in the forward bias mode. So the current starts flowing from this direction, and which opposes the upper half cycle. So we can relate the mathematical equations as VBE, that is the voltage across base emitter terminal, is equivalent to EC sin omega CT plus EM sin omega MT. Similarly, V dash BE, the second half, is equivalent to, the only thing is opposite directions of current due to the phase shift of the input signal or modulated signal. There is a change in the sign current. So EC of t plus EM of t. So we substitute this equation, so we will get this. Then again we have to apply the non-linearity property, square law. So expand this equation, higher order terms are eliminated. So only we will get the first term, and the DC terms in this equation is eliminated. So V0 is given by K into IC minus IC dash. So on substituting the above equations in the voltage equation, E0 is equivalent to K into IC minus IC dash, value derived from 5 and 6 are substituted here. So these two term gets cancelled, and we will get 1 plus MA sin omega MT, where MA is equal to 2A EM by A1 is a modulation index. So this equation represents modulated voltage output, which contains carrier and sideband, but there is no modulating terms. So thus this circuit is used as a AM modulator, and the advantage of this circuit is the undesired harmonics are automatically balanced out, and there is no need of separate filter for filter outing the frequencies, unwanted frequencies. Thank you.